Last time we were able to get a chloropleth going with the kill rate, so to speak, to death per population of the states, that you get a better picture based on, rather than just a population density map, which is often what you get if you just plot something based on the US, such as like, I don't know, how much money is in this state, or any number of other things. A lot of those just reflect population density. So we're going to look at the rate, and just looking at this map, you see some interesting things like, oh, it looks really high in Alaska, New Mexico, and Oklahoma. You're going to see some, I suspect there's some curious statistics going on there. Also, chloroplasts like this can be really, really misleading, because like Alaska is huge, but its population it represents, I'm sure, a much, much smaller fraction of the overall kills than many of these other states. Sure, as a rate, it looks higher, but one incrementally more there could make it look much more impactful. Compared to like North Dakota, where there's very few people, maybe that's in the other direction, just at random chance. We don't know. So Alaska, very low population state. New Mexico, not the highest. Oklahoma, I'm not actually sure. And of course, we have no information on Puerto Rico. But this at least levels it out a little bit. But you see large areas of the sameish color, and green is like the worst color to use for this. I should fix that, actually. The large areas don't actually reflect really how many people are there and how many kills there are in total. Again, because it's like another way of looking at the rate. The areas, your brain will look at it and get real confused, even though there's far more people living here than living in this whole region. That is how it is. Let's go Python Folium, Choropleth, color. Like, how do I want a different color scale? Color scale. Color map? Color scale. Use this one. Oh yeah, that looks good. Some kind of hot red or something. Yeah, let's do that. That's way too many little details there, but that's fine. I have a little function here to make the map, because that makes my life a little bit more sane. Cool. I should add like a save name. Save name equals map.html. And then down here, we will save it with whatever save name we give it. Save name. So I don't always have to do the same thing. Color scale, where do we put the color scale? Whatever this other nonsense, Bronca. Where do you get Bronca? I don't want Bronca. Man, I just want a different color scale that's built into Folio. Oh boy. Oh boy, oh boy, oh boy. Geodata, key on, fill color. Oh, blue purple. That's the fill color option. Yellow to green. So fill color, maybe that's what I want. Python Folium, fill color. Yes, okay, we go to this again. Fill color. Blue, purple, this specific thing. Yeah, I want to know what the possible fill colors are. I don't, like, this should not be a hard thing to find out, right? This should be, like, there should just be a list I can find somewhere. Fill color. Fill color. Defaults to the value option of fill color. Yes, and where can I get a list of available fill colors? Here we go. This is what you needed. So green to blue, orange, red. Is there like an orange blue? Purple blue, blue purple, blue green, purple blue green, purple red. That's not bad. Yellow green, blue. Yellow green blue maybe? Yellow orange red, red purple. Oh, I don't know, man. Purple to blue to green. I hate having green in there because I know green is it's a bit of a pain. Yellow to orange to brown? Let's try that. That might be more relevant. Just to see if we can get a slightly better color going. There we go. Change these to proper single quotes there. I don't need this nonsense. This. Okay. I've already reloaded in all my data. This is, of course, the rate. Here's the old rate. This greens. Now, okay, yeah, some dusty reds and stuff. I like that. Yellow to orange to brown. Okay. I mean, we're seeing the same thing. But it's Yeah, these are probably all about. Oh, there's only 6 bins, right? That's why they look the same. I don't know why. Like, this doesn't have to be bins. Really didn't have to do that way, but that's fine. Anyway, we are going to read in some ethnicity information that I pulled from Wikipedia from all the states for 2015, and then we're gonna make this map. But like, what is the rate for like different ethnicities? And so you're not going to use the population of the whole state, but just the population of the state for that particular ethnicity, or wealth, or gender, like any other things you could do. And then you can get a much more nuanced view of like, these are high, like, are police killing more people of Native American and American Indian descent? Probably. But we'll find out. Or we will make some attempt to better understand the situation, I should say. So, I pulled this from Wikipedia. I've got all the states. It's got various... It's got not the exact same set of ethnicities that the Fatal Encounters has. Fatal Encounters, which is 28,000 some long. Wow. It has race and it has race with imputations. I'm not sure what that means other than... Like, they took a stab at it and they said, well, I think it's this. So actually, let's take a look at that. Subjects, race with imputations. That, and I want to know what all the unique values are. So you get a couple different options, but I don't think these are appreciably different from subject's race. Right? There is... Oh, jeez. I gotta read in the data again. There's a place where there's an extra, like, capitalization here. It's driving me nuts. Careless enough, European American / white. It appears that the space here, too, which is... Like, just pick one. You're driving me crazy. Cleaning the data. Always part of the problem. So I need to read in my data again. Data. And then we need to do things to it again, I believe. Or is it states that we gotta do things to states again. Right. Location, yeah, here we go. Because we have information per state. This is, of course, a little bar chart. So not a choropleth at all. But still generally good way to look at information, quickly to see, okay, large here, kind of varied around the other ones. Compute all this again. There we go. Oh boy, wasn't happy about that. What were you not happy about? Int object has no attribute replace. Can you just do this? Oh, no, you can't do that because I need to read this back in. Because I had already overwritten it and it didn't exist anymore, and then all this other stuff and problems, you know, problems. Okay, that is all fixed hunky-dory like. I like having some random numbers in there too, just because. Okay, let's just redo that. Nothing should actually look different now. This should look exactly the same. Good, it does. Perfect. Anyway, I have this ethnicity, and we have not exactly the same information. We have, where is it? There we go. Okay, so cleaned up a little bit. There's still this nonsense. It's just problems in the data that will always exist. NaN is a possibility? Oh boy. I'm inclined to just use this set. Is there just a dot count? That thing? No, that's not what I wanted. Import counter. I want this. Show me this. And then show me the same thing, but just in the basic. Like, do I have a large number of unspecified? 8,000 some. Versus here we have only 1,000 unspecified. So how is it imputed? Was it just set, like, based on the state? Randomly guessed? About the data. Methodology. Here we go. I want to know, how did you impute? That's unfortunate. No. Hmm. Oh, that's cool. Some different people have done cool visualizations. That's neat. They do not say here. This is like how they put together the data set together. If we didn't know their race, when record is complete, it's moved to a verification queue. Research state by state. No, they don't seem to have that information. If you know, that'd be great. About in the news, why about them? Tools, database name is check, public records tool, maps. Oh, that's cool. I got some maps built in right here. Or they did. Oh, bummer. They don't have enough money for that. So that's why we gotta make our own map. Alright. I don't know how this is working. How the imputations go. Which is, like, if I don't know, I'd rather just leave it unspecified. To me, feels a little bit more fair. You might say, oh, look, more European Americans are killed. But if you look at overall percentages, I guarantee you, these are not the percentages of these ethnicities in the United States. These are your probability of being killed by a police officer and your probability of belonging to a particular ethnicity are not independent events, unfortunately. Yeah, I guess rates unspecified. Almost number one. Almost. Yeah, and of course there's more categories. What is going on here? These numbers even add up? Yeah, I think they do. So it looks like about a little less than half of these, about half of these, go into the European American column. There's only 5, yeah, a bunch of jerks. Go into European American. Another half, another quarter goes into the African American Black. What? How does Hispanic go down here? Wait, what? Okay, yeah. Another 1,000 or so goes on to Hispanic, and a handful in other categories. None go into Middle Eastern. So I wonder if that's just the distribution of the U.S. I would not be surprised if that was the case. It just took those and said, like, well, let me slap those around. Because this still has unspecified with a certain number. Maybe at a certain point they were, or maybe it's based on the state, something like that. Or even the zip code. What is the zip code where it occurred? The zip code where the person lives? All kinds of other problems. Or maybe they looked at the name. I don't know. I'm going to stick with this for now. And if we have time, maybe we'll look at this, just because this is a little bit cleaner. Now the problem is, in this ethnicity, let me read in that data. Like Ethereum, you know? Something ethereal, not really, only temporary, only skin deep in a literal fashion. Let us read in that data. Ethnicity. CSV. Okay, and we got some stuff. Look at the keys. Oh, son of a gun. PD.read CSV. I need the separator to be a space. Separator equals space. It is separator, right? Separate. It's comma separated values. Separator, separator, separator. Is that not an option? What's going on here? I would like to know separator. Really? Sep? Okay. That's the question. There we go. Really? Expected 27 fields in line 4, saw 28. Someone has an extra name. Oh. Interesting. Because there's extra spaces in Arkansas. Also, there's not that many. There's definitely not 27 fields, pal. There's 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 fields. If I do /s. Air could possibly the quotes being ignored from the multi-char delimiter. What? This is madness. Madness, I say. Absolute madness. Also, these are percentages, and these are, of course. You know what? Another thing we're going to do. I am going to everywhere replace these commas with nothing. These commas are not helping. Garbage, they're gone. And then I'm going to fix this again. And just say everywhere. Any spaces? Any one or more spaces. I would like a comma and a space. Oh, come on. Can I not do that? I could have sworn I could do that. Yeah, what do you know? Oh, I know what I need. Hang on. Hang on a second. Oh, this District of Columbia is going to burn me. There we go. Problem solved. Puerto Rico is going to kill me too. Boom. Puerto Rico, West Virginia. How are these handled? Dang it. That is not what I wanted. Okay, let's turn that off. How are the states marked here? States. Yes, they have the proper names and everything and all this good stuff, of course. Here's what I need to do. Let me just fix these manually. You can unfix them later. Do some regex stuff. I forgot how many states had spaces. I ought to remember there's a space in my own last name. It's a thing that's gonna happen. District of Columbia, yada yada yada. Okay. I gotta read it in like this. We're just gonna do some Vim to fix some things up. What I want to do actually is come here. I'm not gonna do this on every line, but I want to replace any spaces with a comma and a space everywhere in this line. See, that's what I thought would happen. That's why /+, that's what I need, I think. Ding! There we go. Okay, cool. Undo that, come back here, now do this everywhere. So this is some Vim regex-like syntax. Percent on every line, S, we're doing a substitution, /, this starts, what are we looking for? We're looking for /s, a space, /+, one or more spaces, any group of one or more in a greedy fashion. The second backslash here says, okay, what are we replacing it with? Replacing it with a comma and a single space. Backslash closes off that. The G means sort of global for this line, so not just the first one on the line, but all of them. Boom. Data cleaned. Look at that. Look at that. Very nice. Much, much better. This means a couple nice things. We don't have to read with a wacky separator. We will read with a perfectly normal separator. So you do this now. Suddenly looks a little bit more normal, but we got these underscores that I put in there. We'll fix that right up right now. Because now I'll do the same thing, except anywhere I have an underscore, which only exists in those names, I place the space, and now they're restored. And lo, behold, we have data. What a glorious day. What a glorious day. 51. Oh, because there's a 0. I see. How long is states? Oh, states doesn't have Puerto Rico. Yeah. Whereas length of ethnicities is 52. So something we need to be wary of. So these are all our actual ethnicities with very, very simple names. This is the population of that state in that year. We don't really need that information, but actually no, we do. This is in 2015. I'm going to use the percentages though here in order to estimate these values, in order to estimate the population. Supposing, even though it's not exactly true, that the percentage does not change from our average, or is not significantly different from the average. If you were doing an exhaustive study, of course, you would want to look at that. Okay, how do we get the right columns from our data? This is this stuff. Okay. They call it race here, so let's call it that. Subject's race. Okay. That's that. How did I do this here? I had to walk through the data, didn't I? And I took the sum, location of death by state equals S for every state. Yeah, okay. So now it's like for every state, for every race. So in my states array. Yeah, okay. What I want, let me grab this. States dot abbreviation by .argsort state dot name. Yes. This is what? It starts with zeros. Number of deaths, the kills in that state. In each state, I should say. And now we want to say location by state, and by which we will use an ampersand, take a logical and data of subject's race equals R. Obviously we don't have that part of the for loop figured out yet, but we will get there. So we're going to make a little matrix for ourselves. And then we'll figure that out. 1 second here. Okay, sorry about that. What do we have? We need to add our other component to this, the states, and we need to figure out how many ethnicities we will consider, and I think we're only going to look at the ones that we have for this information. In fact, let me remove this. But I'm going to need this first, actually. Yeah. We need a way to map these races to these ones. And why are there extra spaces in here? You're driving me nuts, man. You know what? Oh boy. That's really annoying. That is gonna drive me bonkers. Like, I don't mind the numbers, because it understood that they're numbers. But here, yeah, that is a no-go, my friend. Okay, much better. That is much, much better. Let's read in that data again. Let's do that again. Okay, that looks much cleaner. I'm much happier about that. We need a map between these and these. These guys, these guys. So, our R map, which way are we going? I think, yeah, we get to decide which way we're going. Just shorter names make this a little bit easier, I think. So I'll say, given the long name, give me the short name. So this will be a dictionary. Actually, I can just do this. And what we do, I think this we do manually, just to make our life a little bit simpler. Grab this. There we go. And continue on down the chain here. not the most data entry, not the most exciting part of this. Is there really not a Hispanic in this other stuff? Really? That's surprising. That's really... Really? What does it say about, like, New Mexico? 10%. It says most of those people are white. Interesting. Okay. Often that's broken out separately. Actually, is New Mexico, like, multi? These are not going to add up to 100%. The other concern. No, it's not. Interesting. Interesting. Okay, that's just a different Wikipedia US demographics by state. Yeah, okay, I looked at this Wikipedia page a moment ago. I extracted this exact graph. Oh, but it doesn't contain state by state Hispanic breakdowns. Well, that's curious. All right then. That is what it is. Really? Whew. Okay. All right. That might cause some trouble, but that is what it is. That's why solving these problems, or not even solving, just like better understanding these problems, is more challenging because there's so many different ways to categorize human beings, most of which are not particularly helpful. But that is the data we got to work with it, so we're going to try to work with it. Okay. So in that case, this gets mapped to other, I think. That is the best we can do. Much like unspecified, gets mapped to other, Native American Alaskan. That one we actually have. That is, okay, so that's something. Asian Pacific Islander, I think we have that category as well. I don't know what Wikipedia used to decide what was worth including or not. I assume there's some criteria. Middle Eastern gets put in other. It's actually a really very small number in terms of this data set. Other. Now then, did I not have any in Asian? Oh, Asian Pacific Islander. Oh, son of a gun. All right. So there will not be any put into Pacific. All right. Well, Hawaii, I'm very sorry. Your numbers are going to be really far off. That is how this is going to break down. Even this, actually. Like, this maybe should be Nan. We won't even really be able to fully understand this. Apologize. I am just one man working on this data, trying to get a grip on it. Okay, that is our map. That is not the right way to do that. Oh, extra, comma. Okay. There we go. Okay, now we have some stuff. Got this. This is all this stuff. Good fun, good fun. We might go back and futz with the imputed, now that I think about it more. Anyway, length of how many ethnicities are we considering? That's exactly this information. All right. So it's whatever this is minus 2. Let's see. Oh, it's exactly however long this, the unique values of this dictionary are, I guess. Unfortunately, that seems to be the case, yes. So, length rmap.values set. How long is this set? How many different things are we going to end up with? Is the question. Okay. So, This, I don't want to use S though. Use R. There we go. Okay. It's this. That's this. That can still be S though. And for R in S. Hang on. Ah, I see. No, that's not R in S. No. That's all eth. These are all the ethnicities we are considering. This is exactly this. If I could, we will sort this. There we go. All eth. Perfect. And then we can just call the length of that rather than doing this over and over again. Okay, that's a little bit clearer. So we'll say for j comma r in all eth every time. We'll step down, and we want to know, son of a gun, I needed to go the other way. Son of a gun! I need a map from here to what race I'm considering, which really means isn't exactly what I wanted. No. Can I? Right, is there an easy way in pandas to remap? Pandas map new column. The mapped value. Is this an easy thing to do? Column with a dict. Well, that's actually pretty good. 1A, 2 to B. Yes, you want to turn 1s into A's, 2s into B's. Replace. There we go. For a particular column, presumably? Or directly on the series. That sounds like what I want. For this particular column, do dot replace and do it in place. And this is our dictionary of consequence. Okay. So, this is on the actual data dictionary, but I don't really want to replace it. Okay. I will say, but data of ethnicity, just to make my life a little bit easier, is going to equal a copy of the data of subjects race. And I think it's actually lowercase. Yep. This should look like this. Okay, now we're going to replace. Fix it up. And then here we can use this directly. We don't have to use the map except for this. Because we will say data eth dot replace. What is our replacement? This map. And in place is equal to true. Okay, our map exists. Yes. Unexpected keyword in place. Okay, how does that work then exactly? I'm sure I just mistyped it. That's cute. In place, one word. No, nothing there. Okay, and now we look at data eth. And you see it's all a bunch of these others, white, black, Asian, etc., etc., etc. For every single one. Yes, because I don't think we had nan as an option even. Yeah. No, nan was not even an option. We've gathered all these into one. It is what it is. That's gonna be fine. Then we step through for every state. We ask, were you killed in that state, and are you of this ethnicity? And we're going to put that into this matrix. How many values to unpack? Expected 2. Alright. This is enumerate again. That's what we needed. Can I compare a D-typed object array with a scalar of type bool? Well, that's a bit of a drag. So let's just run this and get dropped into wherever it's doing some nonsense. Okay, now we can see what the problem is. Like, where are we at? J, okay. On the first one, so it's probably just the general problem. Okay. So, are you not able to just get this? No, you can get that. And I know you can get this. Alright, let me kill this. Save that off. Grab this. Save that off. AA. BB. AA and BB. That's totally fine. And can I take a sum of that? 1. Sure. For whatever the given state we're in is. Alabama. And whatever race we're looking at, which is Asian. I'm willing to believe that number. And why doesn't this work again? I feel like this ought to work. Feel like it ought to work, you know. Given that we just did that. We just showed it working there. Oh, I know what the problem is. I know what the problem is. We don't have enough parentheses. There we go. It was trying to do S and data F and order of operations. It matters. Lo and behold, boom, done. Takes, half a second. But now we've got this big matrix. This is wrong. Oh, son of a gun. Put in the wrong one. I gotta rebuild my regular state death matrix. Now. Come back up here. That's what I get for overwriting things, Go down here. Do this. Okay. That's much better. Yay, we have some things. This is suspicious. Ah. Put it in the right spot. Don't fill up the entire row. Important things to check your data. Get a sanity check. Right? Okay. Now we're getting somewhere. These really should be integers. NumPy.zeros. Change the type. NumPy dot, I don't know, int32, whatever. NumPy.int, that's fine. Cool, now we have a whole bunch of integers. Now I want to plot the... I'll just do imshow. No, that's not gonna work. Mate show, that's what I want. Yeah. Matrix show. Okay, cool. And again, this is pure numbers. And each column here is your ethnicity. Each row is one of the states. So one of these states, whatever state this is much higher than the others. Probably just due to the population. Again, probably California, New York. Many more people. And so that's why you're seeing this kind of construction here. Okay. Cool. We have that matrix. This is your deaths by race. What I want then is use this ethnicity information, to look at the rate per race. So I will need to build the population, build the expected population for every state for every race. Right. So it's like really we ought to do the same damn thing here that we did there and all this other stuff. Okay. But I don't want to use their numbers here, really. I don't have any particular reason to trust those. I just want to use these numbers, these percentages, to get me the numbers that I need for my states array. This states has population. Yeah, so this is like the overall population somewhere. Somewhere in there. Population over the years, and there's an average pop. Boom, that's what I want. I want the population for every race, and then I want all this information, right? All the information in this matrix, and then I want all the information for the population as well. Okay, so I think I want another set of these things. right. I could say states. How do I want to put this? New column. Like, so for example, states Asian, because that's the first one. Let's work out a little detail. This is the number that were killed, and that is equal to. Why would you do that? Not what I asked for. All of the rows, all the states, right? Just the first column. Okay, so what I want to do is for, okay. I, comma, R, in enumerate all F. Stop it. Python's trying to be too smart, Python's being dumb. We are going to take whatever that ethnicity is, R, whatever that column is, I. Then we will also do some more things. R plus rate. And that is going to be the count for that divided by that state's population. Hang on. I'm almost there. Right? You want like average pop times, I'm gonna have to put it in the states array, right? Not the average pop, but the, oh, we're so close. Right, we have a map all ETH here. No. Is the order of these states, which are in alphabetical order, actual alphabetical, right? Not alphabetical by who's it, what's it? Is that the same as in, might missing information? I have Puerto Rico as well, but other than that. District of Columbia, for example, comes just after Delaware. Okay, good. So this would be the same order. So, if we looked at ETH of R, divided by 100, of course, and hang on, I don't want this Puerto Rico. You know what? We're gonna fix this. I'm very sorry, Puerto Rico. You're not a state. Neither is DC, but DC is in my other list. Again, I'm very, very sorry. That is the situation that I'm working with here. Okay, now that's back. Now I'll have the same length item. And now we'll take our state's average population times the percent for a given race, which should give us an approximation to that state's population for that race, which we will divide into the kill count for that race in that state. And in fact, we don't need to do that. We already have that right here. Okay. Let's see how bad I screwed this up. All right, that actually looked not crazy. So now you're going to see a whole bunch more keys. The rate, the kill. This is for a given race, the count. This is for a given race, the rate. Okay. Now, let us go to our mate map. Do the same thing. And just look at, for example, Asian. That's the first one there. And this is the count. Remember the count, not the rate. So you still expect California to be much higher. Come back here. Okay, it's much higher, but the numbers themselves are all much lower. California's way up here. Most of them are very small, just because there's not that many Asians or Asian Americans living there. But if I look at the rate, in fact, there's probably a significant number that are 0. Like, you think, oh, this is terrible. But you should also consider, like, if there's, like, 1 in here, like, let's actually, like, you would want to count it up by race. Actually, how do I change the number bins in my chloropleth? Bins, 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 bins. Because I don't like 6. I want more. Bins? Custom binning can be achieved with a bins parameter. What if I just want int or sequence? Okay, default 6. Default 6 is dumb. I don't like 6. Bins equals 16. I favor powers of 2. Okay. Ah, come on. Can I not use that color scheme with a custom number of bins? What is this? If not explicit scheme, to make sure it's not a qualitative scheme. What? Oh, come on, come on. Pandas, folium, bin, no. Folium, choropleth, bins. Color, like, what if I don't put in a color scheme at all? What happens then, I wonder? Let's just for the sake of argument, just do that. No color, yes. At this point, I don't really care. I just want this to work. Ah. Yeah, that's great. The color scheme, not the most important thing to me right now. So I will make a... Really? Really? That's really surprising. Okay. Folium.choropleth. Really? That's nutty. Finds a number equal with bins. If bins is a sequence, directly defines the bin edges. For more information on this frame, yeah, I understand how bins works. But if it's like not a multiple of 6, do I have a problem here? That's just wild. Keep that color. Come back over here. Bins equals 6. This is just... I did not expect this problem. Okay. Bins equals 6. Right, that should work. Okay. Bins equals 12? Does it have to be a multiple of 6? No. What is going on? If not explicit scheme. Only if n is greater than the scheme length do interpolate values. How long is the scheme? If scheme info base code equals qualitative. And the problem here is what? Key error. That's not in my scheme info. This is like a problem with Folium. Right? Folium, color scheme, custom bin, maybe? This blows my mind that it's broken, frankly, in this way. I continue to be disappointed in Folium. It does some cool stuff. Bins, custom color scheme for choropleth. Indeed limited to color brew schemes. Oh boy. Okay, fine. Maybe I won't deal with that. We'll just stick with bins equals 6. That is mindable. What about 8? Like, can I go to 8? Okay, I can do 8. That's something at least. 8 bins now. How high can I go? 10? No. Alright. 8 it is then. Anyway. I was saying, this looked real bad, but there's just, the actual counts are just not going to be that high. Because it's going to be very small. Alabama is like what, our first, that is Alabama, right? Yeah. Now, the Southerners are going to be real. Like, clearly Louisiana, Mississippi, Alabama. I can figure this out. I can totally figure this out. Right, okay. Mississippi now is, of course, one of our states. Is this gonna work? No? Come on, come on. What is the deal? There it goes. Okay, just takes its good sweet time. That's gonna freak out a little bit. Yeah, these are almost 0. Why are you... This is horrendous. Stop it. You can see in the lower right here, like the actual count. So Mississippi, M-I-S-S-I-S-S. We can actually just look at the states. And get the index of it. It starts at 0, Mississippi, boom, 24. So 24 over here. I think that's bigger. 24, right? Yeah. There's 5, maybe 7. And just their share of the population is very, very small, I'm sure. If you look at, is it ETH? Yeah. Over here, Mississippi. Yeah. Well. Oh, well, that's. Yeah, there's an Asian column in there, but I'm sure that's what the problem is. Whereas if you look at, I don't know, let's look at white. Look at white people. Again, population map, particularly since the plurality of the country is Caucasian in some sense, that's what this map reflects. Let's do this, except let's make the, what is it, save name, I think I called it? Save name. Yeah, I want to be able to look at this quickly. Save name equals the white rate.html. And speed, just for giggles. Okay. Make both of those. And then, this is no longer just a map, right? The rate. And the rate. Okay. And I think you'll see this is the black rate. Also note the scale change here. 4 times higher. Not every state is actually darker. Curiously, probably just because there's very, very few people with fewer people with darker skin in some of these states. Man, what is it about Oklahoma? That is wild. I mean, it had a much higher rate overall. New Mexico, not that much higher. Similarly, black, so like there's some other ethnicities overrepresented in killings. Police killings here, whereas most of these other states, significantly higher. In fact, if we look at the overall map, let's just do that. We'll just call that just R. Make our life simple. That can help us get a sense of what's going on. And again, we're not doing are these statistically different? Right, we're just looking at a couple of maps. Yeah, of course, the rate is much higher. Note that this brown, this color, doesn't represent the same thing as this color. We would have to set the rate independently of the data itself to that, which would be a good idea if you were doing a rigorous statistical analysis of this, of course. But yes, I think that's kind of the obvious story here. And I've seen some people look at like ask, like, why don't we just do a factor analysis of, what is this ethnicity rate in the population times what is the criminal rate among that ethnicity times what is the rate of encounters with the police times yada yada yada. The problem is those things aren't independent of each other, so the factor analysis doesn't work. You need to strongly decouple those things. If you wanted to say, one way to do this would be to predict what is the probability that you get killed in an encounter with police. That the police kill you in an encounter, I should say. I should use the active voice. And you will throw a lot of parameters into this model. Maybe just build a simple linear model. We're not going to do that. But it'd be like where you live, for example. What your socioeconomic status, those kind of things. And like you throw ethnicity in there. Once you've accounted for everything else, if ethnicity is still a statistically significant factor, that's how you identify the problem. Here, overhaul New Mexico. Let's do one more, actually. I suspect this is what the problem is. That is my definite suspicion. There's a higher percentage of people of Native American descent in New Mexico, or it's probably that or Hispanic. No, okay, not that. Oh, hey, what do you know? Higher percentages. New Mexico, similar percentage as Minnesota, I think, in terms of Native American people of Native American and Amerindian descent. But wow, Iowa, and again, super high rate there. This scale is very similar to this scale. So that's also super bad. Again, Hawaii, I'm very sorry. I don't have the Hispanic information. That's probably who the police are killing in New Mexico. How it works out. Yeah, is there a place in America where being white means you're more likely to get killed by police than if you were black? I doubt it. Maybe Montana? Yeah, maybe Montana. That's like 0.006, which is just about over here. This is the lowest one. Yes, in Montana. Go figure. Go figure. That is just about the only place. Again, this is the overall, the everything. All right, I think that's all I'm going to look at for tonight, and that's as much as I'm going to look at this data set. Again, if you wanted to do a rigorous statistical analysis, build that model, predict the grim probability the police will kill you, look at the input features. Do they have a statistically significant parameter associated with them, positively or negatively? That is one way to look at that. Your model doesn't have to be super accurate, as long as you can help you determine, is this feature significant? And is it significantly different from 0, that is to say? Is it significantly different from? It doesn't matter. I suspect you will find that it would. Just looking from these graphs. But these graphs are not a rigorous statistical analysis. All right. That is all I have for tonight. I hope this was insightful. Stay safe. Stay safe in the data mines, and stay safe.